Hello friends, today's lecture is on Turing machine and we are covering following topics in this lecture. Limitations of FSM, characteristics of Turing machine, components of Turing machine, definition of Turing machine and elements and working of Turing machine. We know that there are certain shortcomings in finite state machine. Because it cannot have memory, it cannot store intermediate result. That is the reason it cannot solve the problem that need intermediate result for the further execution. Second limitation is it has only one read head that moves in right direction. As it cannot move to the left direction, it means it cannot use the data, that is the previous data which is stored on the tape. Third limitation is it cannot work with large number of input symbols. Because FSM does not have memory, it cannot store large sequence of input symbols on the tape. Due to these limitations, FSM is not able to solve the problem to check whether the parentheses are well formed or not, or to check whether the input string is a palindrome or not. To overcome this problem, we need a very powerful machine that will have the following characteristics. First, the finite state control. It is similar to the FSM where each state has given the specific task. This is what we are doing in our normal program also, where each function or a state has given the specific task and our entire program is divided into the smaller modules or the functions or the state. Second characteristics it should have is the external memory. It should have the one-dimensional infinite memory so that we can store any large amount of data on the tape. Third characteristics which the machine should have is read and write head. As we can read the data from the tape, it should have the ability to store the data or write the data on the tape. Last characteristics and which is most important is it should have ability to store the intermediate results. It should have the ability to consume its output or intermediate result for further computation during the execution. And Turing machine satisfies all these characteristics. Turing machine is very important mathematical model in TCS subject. It is also considered as powerful computation engine. It is also said that Turing machine is a standard or a threshold that tells about the computational capacity of computer. That is what computer can do and what it cannot. Just like a language generator, acceptor, Turing machine is also acts as a transducer. So it can execute any mathematical function like addition, subtraction, log, antilog, etc. So let's see the definition of such a powerful Turing machine. Turing machine is a set of 7 tuples: Q, sigma, tau, functional matrix, Q0, capital B and capital F. As I said, it is a set of 7 tuples, so this order can be changed. So out of this 7 tuples, the 4 are same as what we have already used in finite state machine. That is Q, which we have already used in finite state machine. So capital Q is a finite set of states. Sigma, it is a finite set of input symbols. Then Q0, it is a start set and the functional matrix. Now here we have 3 more sets, that is tau, then capital B and capital F. So tau is nothing but it is a finite set of allowable symbol on tape including the blank B. As tau consists of all the symbols which are available on the tape, so that is the reason why the sigma is also called as a subset of tau. Q0, it is a start set which belongs to the capital Q. F, it is a final state which is also here final state can be 0 or more number of final states we can have, and that's why the F is also the subset of Q. Then capital B, it is a blank character. So capital B represents any character which you can use to specify the blank on the tape. So this character is also the part of tau. And the last and the most important is a functional matrix. So here transition function is denoted as Q into tau maps to Q into tau into the direction. So it means that input is given to the state Then machine is transited to some other state. Some symbol is written on the tape and the head get moved either to the left or to the right direction. For example, suppose symbol A is given as an input to state Q1, then machine get transited to state Q2. Symbol B is written on the tape and head get moved to the left direction. Now we'll see the execution and the components of Turing machine. This is the one-dimensional tape where this tape is divided into the number of cells. Each cell is capable of holding one character or a symbol at a time. You can see the tape is a one-dimensional and it is infinite on both the sides. This is the input string. The input string is surrounded by the blank spaces to indicate the end of the input string. All these symbols from the input string, it belongs to the sigma, and all other symbols including the input stream which you can find on the tape, it belongs to the tau. Next important element of the Turing machine is a read-write head. You can see that the head is pointing to the cell where we have a symbol A. Now depending upon the task given to the state, either the head will get moved to the left side or the head can move to the right side. Currently the head is pointing to this cell. It means the data can be read from this cell, or we can write something to the same cell. The next important element of the Turing machine is finite set of states, which is denoted as capital S. So here this S will hold all the states which are there in the capital Q. So any state from the Q will read the data from the cell where your head is pointing, and depending upon the symbol which is read, some action will be performed by the state, and then it will move to some other state and the data will be written on the same cell where your head is pointing. So in today's lecture we have seen limitations of FSM, definition of Turing machine, characteristics of Turing machine, working and execution of Turing machine. I hope with this you must have understood the importance of Turing machine, its components and execution. And in the next lecture, we will solve some problems on Turing machine. Thank you.